The following is an episode with Laurence Griffiths, former Principal CFD Engineer at Williams Racing. Laurence has a PhD from the University of Bristol. He has spent over 12 years in high-performance motorsports, 10 of them being at the pinnacle of motorsport, Formula One. Laurence is now the founder of INNEXA, a venture driven by a deep passion for engineering and innovation. You can read more about INNEXA from the link down in the description below. In this episode, Laurence talks about the effort it takes to build a Formula One car, what's it like being behind the scenes in the fast-paced Formula One world, and share some of his advice for upcoming engineers. Hope you guys enjoyed the episode. Well, Laurence, welcome to the show.
Thanks, yeah, it's great to be here.
So you've had a decade of experience working at the pinnacle of motorsport, which is at Formula One. So can you just give us a glimpse into what's it like working in Formula One?
Yeah, it's very varied, I'd say. And the thing that I enjoyed most about it is the pace that Formula One works at. So the timelines of projects, it's very rare to have a project that will last longer than, say, 3 months would be a very long project. Each year you've got to get a new car to track. So normally when you're developing something, you kind of have a couple of weeks or something like that to make an improvement. One of the biggest things I'd say is you're always making incremental improvements. You're always trying to make something better. You might have a new insight that an aerodynamicist is trying to discover. So then you might be trying to create a new simulation to exploit that new theory that they might have. Or you might have a problem that you're trying to solve and you've got to fix that within, say, either next day or within a week or something like that. So I'd say the biggest takeaway from it is just the pace of it, really.
I see. Yeah. Now, just so you mentioned the word projects, I just describe that a little bit because to a layman myself, like when I see a Formula One car, it looks fancy, it looks pretty, it looks weird, not like your usual road car. Now, it makes noises, it goes fast, like that's what I see as a layman. But give us a glimpse into like the amount of work it takes and like this project word that you mentioned. Like, what are all these many things that all come together to bring like a Formula One car to life?
Yeah, I mean, I guess in total throughout the whole business, you would have like 800 people working on an F1 car to get each year to get that car to track. And then within the different sort of groups within an F1 team, so you've got people that will be working on, say, the chassis side, you get people working on the aero side. I've been in on the aero side my whole career. So you'll have a group of aeros who are trying to exploit the rules to get the most performance when you go to track. And then the kind of projects that we work on within the CFD group are you're trying to give the aerodynamicists a tool that can, as reliably as possible, give them the right answer for when their design goes to track. And that's where in CFD kind of we spend almost all of our time. So the aerodynamicists will design parts. They'll run that through CFD. They run that through wind tunnel. If the part works out, it'll go to track. Obviously, to make the most out of your CFD simulation. So within a CFD simulation, what we're trying to do there is visualize how the air moves around the car. So obviously, you've seen the wings and everything on the car. And CFD is the only tool that allows someone to physically see what the air is doing. And then you've got wind tunnel testing. But in the wind tunnel, you get kind of little glimpses of information, but you don't get the depth of quality that you get from CFD. And then you've got track testing, which is the actual truth. And then you can see even less when you go to track, so you might have a few sensors. So yeah, for us, a project is all around can we make our simulations as fast and as reliable as possible, really.
I see. So you mentioned the word CFD. What is that for people who don't know?
Computational fluid dynamics, and so it's a way of solving a set of very expensive equations to kind of see what the air is doing around the car. Within the rules of F1, we're limited by how much compute resource we can spend on solving these equations. So typically we make lots of assumptions to sort of solve them quicker, but the more assumptions we make, we've got to sort of, I wouldn't want to say the less reliable they get, but you've got to understand the assumptions you make a lot more. And then you've got a lot of tuning and things like that, because if you're solving, you're kind of removing parts of the equations and you're replacing them with something more simplified to make it faster. And that's where in CFD, the engineers will spend a lot of their time finding tricks to remove something that's expensive to compute by some approximation where you might have some insight, you might know the answer to it, and then you can sort of put that in directly.
I see. Okay. So let's take a step back. Now I want to go into just your career journey so far. So what initially drew you to work in motorsport?
So if I go all the way back to when I was in uni, I really loved physics, but I didn't really know what I wanted to do with that. So at the time, I pursued a career in aeronautical kind of stuff, and I sort of knew maybe I want to do aircraft, maybe motorsport. Wasn't entirely sure. So I think the thing that drew me to motorsport was sort of it's a crossover between stuff that I really enjoyed, so physics, but then also I guess the pace of it, the kind of the excitement, you get a car to track, it's something measurable, it's something which happens every year. You kind of get immediate feedback to what you're working on. You don't have a 10-year sort of turnaround cycle to see what you've designed. It's kind of a continual measure of how good are we right now. I think that's really for me what the excitement is.
I see. Yeah. So your initial journey started with an interest in physics, not necessarily motorsport, but
Yeah, that's
then
right. Yeah.
inclined towards motorsport. I
Yeah,
see. Okay.
basically, yeah. Yeah, for me, motorsport initially was just a way to get into kind of really sort of applied physics. Was the main kind of draw for me.
I see. So your the last role that you had, so you worked at with Williams Formula One team. The
Yeah.
last role you have was being a principal CFD engineer. Now, what are some of the responsibilities of, say, now obviously it has the word principal. Let's compare that to, like, say, a junior role in like the in a Formula One team. Now, how much does your level of responsibility increase? Like, what's that like?
So at the principal level, you're responsible for the general work output of a group. So let's say you're trying to improve your CFD model or your simulations. At a junior level, you would have quite a lot of input still to sort of brainstorming discussions on different things you can do. But typically, you'll end up with tens of ideas on how to solve a particular problem, and then as a principal, your role is more to prioritize and to either encourage other engineers to take their ideas forward, but also to, from all the ideas that are there, to know which ones to chase and know when to back out of an idea or when to push other ones forward, when to pivot from an idea. And so I think that's kind of usually where your role as a principal kind of comes in. Yeah, it's more around knowing what to chase.
I see. Okay. So just following along this chain of thought, I one thing I've always been curious about is how the drivers' feedback play into what the engineers are working on. So what is that like? Like, do the engineers provide like a selection, like a selection of solutions for a problem, and then the drivers kind of give their feedback one by one, or does it go the opposite? Like, do you guys lean on the driver's initial input first, or how does that dynamic work?
So there's a few ways around it, but in general, the way it works is from the track tests and the track areas will distill down what the fundamental features that the driver is asking for. So the driver might want certain types of behavior, or there might be problems with the car, so the driver can't exploit the full potential of the aero package that you've got. So out the back of that, they'll sort of present to the aero group what sort of aero trends and what sort of aero features the driver wants to put more performance on the car. So I guess it's a two-way sort of thing. You've got the main aero leaders who are saying, to make the car faster, this is what we need to do, and then you take into account then the feedback from the driver, who's then saying, yeah, this is really great, or no, I've got problems, I can't exploit what you've put on the car because I can't drive within these limits. So it's kind of a two-way discussion, really.
I see. Okay. Well, let's stay on this theme for, let's say, like designing solutions to problems to like exploit different areas in, like, say, aerodynamics specifically.
Yeah.
How has, say, like the like AI impacted this field of work? We've all been aware of like the recent craze in AI, like AI and everything. So how has that impacted like some of the work that goes on behind the scene, like say in motorsports?
It kind of makes some things which you would typically spend a lot of time doing, it just makes it a little bit faster. So the general way of working doesn't really change in terms of the types of problems that you're solving. It just ends up being an additional tool in sort of like the arsenal that the engineers have got to work with and to exploit. So it kind of falls into the theme of how can we do more with the resource that we've got, and things like tools like AI is just another tool in that tool set to make you get to the right answer faster.
I see. So I guess what capacity is like artificial intelligence technology used in? Is it like for generating? Because I come from the software world, my context is like just it. Like for example, my go-to tool is like Chat GPT for basic like coding problems, debugging, etc. So like that's my level that I'm operating at. But then for say something like CFD work in CFD, like how does that impact with like generating car designs or like designs of parts, etc.? Does that work in that capacity?
I think with AI, it's important to understand how these different models operate and kind of what they're good at and what they're not so good at. So I guess things that engineers are very good at is creating new things that have never been seen before. Um, but in order to be able to create these new things, you need lots of simulations and things like that to inform the engineer of where these sort of lucrative design areas on the car are. So tools like AI, they augment the simulation set that the engineers have to work with. So you've got CFD simulations, you've got various types of CFD simulations. Some are unsteady, some are steady, and then you've got your machine learning kind of tools as well. I wouldn't say at the moment we're not really in the space where AI can kind of give you a completely new shape better than a well sort of trained and engineer can. I think you can use it to sort of optimize and refine, but I guess the actual innovative rule exploiting kind of ideas, currently that's still done by humans.
I see. So you can't ask like an AI, like give me the perfect F1 car or something like that. Still a long way down. So,
Not yet.
yeah.
Still a little bit to go on that. Yeah, yeah.
Now, how does okay? So this is something I've always wondered about. So I have, and for context, I have very limited knowledge of like the mechanical engineering type of world, like actual applied physics, like when you actually bring like a mechanical system to life. How does something actually get delivered? Like my understanding is like in the real world, it's like physics is very complex. You can always improve on stuff. You can like everything can be more efficient, more better. Like how do engineers actually say like, okay, this is good, let's move on to something else? Because you can always, my understanding is like you can always improve something that's already there, like make it more efficient, etc.
Yeah, well, you've hit on a really good topic there, because that is one of the challenges which you face in Formula One is when do you bank an idea and when do you keep pursuing it? Um, typically the way it works in Aero is your wind tunnel tests, they're always running. So you're always doing something in terms of throughout the whole season. You're still developing the car. The decision when to move on is really depending on the rate of improvement. If a given idea is when you're still doing wind tunnel tests and you're still working on it and you're still getting a lot of performance out of that part, then typically you'd keep pursuing that sort of idea. But typically what you see is after a while you've got your steep gradient where your part where you haven't exploited it fully yet, and then it always tails off, and then that's when you need a good balance of new ideas coming in so you can stay on a steep sort of development gradient. But knowing exactly when to switch, that's a battle that faces F1 teams every year, really. Yeah.
So that's part of the job, basically, to figure
Part
out
of the
when to.
job, exactly. Yeah. Typically, the way to sort of to answer a little bit more on how it works, so you've got your continuous development, which will typically get done in your CFD simulations, and then you've got your wind tunnel tests, where you tend to bring kind of a collection of some of these ideas that you've tested in CFD, and you put those through wind tunnel tests. And then the most expensive thing is to put these ideas into a track test. So to make the full scale part is when you've got all your tooling, and just the manufacture of the components starts to get quite expensive. So typically for your track test, you start to pull various packages together, and then you try to deliver a package to track.
So what percent of the initial ideas that were initially being tested on like simulation and stuff actually make it out to the track? Like 5%, 10%?
I don't know that number, to be honest, but it's not as high as teams would like it to be. And if you can, any team that can increase that success rate of ideas going to track and for the ideas at track to perform well, will outperform their competitors. So that's kind of where where all the kind of the secret end performance of a team is. How many of your ideas can you convert to successful track components?
Mm-hmm. So you mentioned competitors there. Another thing I've been curious about is how much do other Formula teams influence, like say the team that you were working on, like the decision that you guys make. Is it a lot of drawing inspiration from others, or like how much time do you guys spend like studying other cars, like what they've done?
So you always analyze your competitors. It would be a little bit sort of, I mean, yeah, I think it would be too sort of arrogant not to really to sort of analyze what your competitors are doing, to spot have they had a better idea than you have. The problem you've got of analyzing your competitors though is that it always puts you on the back foot, because by the time they've got that part to track, if you want to draw inspiration from that idea, it's then going to take you multiple weeks in order to get the same idea to track. So it it definitely doesn't form the majority of your work, because the majority is for the next kind of season, and then you're trying to put an idea out that your competitors haven't. But every now and again, someone turns up with something that's completely different, and then there is some amount of resource spent in trying to analyze, is this a better idea than the current ones being developed.
I see. Yeah. Just one last question on this bit. Something I've always wanted to, I've always wondered, which is, the cadence at which Formula One works is obviously extremely fast. Every season you have a new
Yeah.
car. You can't really use your previous one. So say this season a new car is launched. There's some aero flaws that are seen, like areas of improvement. How much time is spent working on like improving the current car versus just looking into like just the next season, Because my
A lot.
assumption is yeah, so my assumption is that if like you start with a car doesn't really perform well, oh well, we'll try again next season. Like, is that common, or do teams still commit to like fixing the current car?
Um, it's not that common for a team to almost give up on a year, purely because the rate of development through the year is so high that um, it's quite common to end up in a scenario where the winning car at the start of the season would be the slowest car by the end of the season if no development was done on it. So even through the season, all teams are normally quite aggressively trying to bring updates to track. It does sometimes happen if a team is really trying to turn things around, that they do less development on a particular season just to get a head start on the next season. And it's if a team does something like that, it's mainly either you've got a rule change coming up, and then the team wants to exploit that rule change. So I'd say in that scenario, it is quite common that you see teams switching early. So not quite doing zero development, but doing much less development in order to exploit a new set of rules coming out. But other than big rule changes, it's quite rare for a team to do something like that.
I see. So they still commit to fixing like the problems that they have at hand.
Yeah, and quite often, if there's not a rule change coming, then the components of the car which you're taking to the following year, they're not always that far different to the existing year. And so you're almost missing out on a lot of valuable track testing. You know, taking ideas to track and testing them out if they're actually working. If you don't develop through the season. So I guess that's a risk that people would have.
I see. So you've spent a decade almost in the world of Formula One. Now that you've departed ways, and one thing I want to know is, the like the just give us like a bit of a brief on what you're doing now, and then your transition out of the world of Formula One.
Yeah, so right now I've started my own company, and that's doing offering CFD consultancy to other motorsport teams. So the main transition out for me, I mean, I really loved working in F1 and I really enjoyed working at Williams as well. So it wasn't a case of getting annoyed and sort of leaving. It's just wanting to feel that challenge again of something completely new. And so for me, yeah, I think it's sort of being in a position where you're sort of forced to learn again and generate a new idea.
I see. So can you talk a bit about your own company, INNEXA? I think is the name.
INNEXA, that's right.
Yeah.
Yeah.
Yeah. So
Yes.
what's the core mission of INNEXA? So,
So at the moment, we've kind of got two kind of missions. One is to try to close the gap a little bit between what's happening in academia and what's happening in industry. So um, quite a typical model you see is when new codes or new ideas get developed in the academic world, then you'd get these sort of big powerhouses of simulation codes adopting these ideas, and then it ends up in industry that way. Um, One of the visions that I have with INNEXA is through open source code, sort of giving academia the tools to get their ideas and their research out into engineering companies a lot faster. The other vision is based more around AI and also academia based, but this time more on the student. And it's leveraging the sort of, I guess, the boom that we've got currently with large language models, and to use that to help various parts of education that haven't quite got the attention that it has so far. So more kind of around accessibility of education, but for students who don't fit the typical mold of how exam content and educational content is written. And I think AI offers a really unique opportunity to tailor educational content specifically for the student, if that makes sense.
Yeah, no, definitely. So what was the main kind of one motivation you mentioned obviously was a change, like the joy of like starting building something from
Yeah,
scratch, like your own company. But in terms of like picking what solutions you want to provide out to the world, like what services, how did you land on these two core missions?
I think they're both kind of driven, I guess, from what interests me most, in a way, and I think that's really important because I think it's kind of you got to find something that you're really passionate about, and then I guess all the work that you put into something kind of doesn't feel like work then because it's something you're really passionate about pursuing. So for me, that's where those two kind of things come about. I really love research, but I also really love the pace of engineering, especially in motorsport and F1. So being in a position where we can speed up getting new ideas from research and getting that into F1 just resonates a lot with things I'm passionate about. And also with the sort of the student exam or the learning sort of type approach. Yeah, again, it's something which I'm quite passionate about in terms of making educational content a bit more accessible to a wider range of people. Yeah,
That's it. So long, I guess along with accessibility, like personalization, personalized learning would be a part of that as well.
definitely. Yeah, yeah.
Perfect. So, what are some of the challenges that you are facing, or do you foresee like that are in this space of like developing these AI tools specifically for education, like in the context of like engineering? Like, what are some of the roadblocks that you have to navigate, pass through to like bring this vision to life?
The biggest roadblock is resource. Finding the time to to develop particular ideas. Obviously, the easiest way to solve that is to scale up. So to get more engineers on board to pursue those ideas. So I guess yeah, it's a bit of a balancing act of yeah of resource, knowing when to scale up and when to continue with as a small company, basically. Yeah.
Yeah. So, what are some of the lessons that you learned like during your time in Formula One that now apply to now you running your own company, like from the managerial side, operational side? Like, what are some of the key lessons that you think are really crucial that you kind of took with you?
The biggest lesson I think that I take away from my years in F1 is not to let perfect get in the way of better. So it's I think that's a mistake that I went into a lot in my junior years was um, knowing all the shortfalls of an idea and wanting to iron all of these shortfalls out. Um, and some element of that is as a junior engineer, you're always sort of battling sort of your own sort of confidence in things that you're doing. So if you know something can be improved, you kind of want to improve it before you put it out there for people to use. Whereas one of the things that really comes out when you're working in Formula One is if something is better, release it because if it's better, then it's always better than what's currently there. The cost of doing nothing carries quite high penalties, quite a high cost. So for me, it's not letting perfect get in the way of better is my main lesson. Yeah,
Yeah, that's a quote you could put on a T-shirt as well. I like that.
yeah.
I guess, yeah. So it's just to focus on INNEXA a little bit more. So you mentioned one of the goal for you is kind of bringing this gap, making this gap smaller, the gap between academia and industry. So how do you foresee like this making like the playing field that people in like in the players that you have in industry? How do you foresee like this impacting? Well, obviously with the work that goes on in industry, you would obviously get new ideas faster, better ideas. But then, how does this help academia as well? As well, like in this whole process.
For academia, it helps quite a lot because you're getting much more visibility on the work that's getting done. Um, I think sometimes in academia, people don't always fully realise how good some of the work is, and I think it comes down to this notion of not letting perfect get in the way of better. In the With the academic mindset, you kind of almost always striving for perfection because you're putting your work forward into journals and then it gets peer reviewed, and then if there are gaps or there are things that should be done better, then it kind of comes out, and you end up in a scenario where you don't want to put it out yet because in the next steps you can make it better. But sometimes what is already there is already better than what's currently in industry, and it's sort of, I guess it's giving people the confidence to try to push what they already have, what they've already presented potentially in a journal or somewhere else to try to get that out faster, really.
Basically, like giving them the spotlight, better visibility, better traction. Yeah.
Yeah, exactly. Yeah, yeah.
Yeah. So so obviously you've done your fair share in the academia world. You have a PhD. Do people in academia mainly solve problems so that they make it to industry, or is that a common motivation, common theme?
The end goal, yes, is to get it into industry. The one of the things which academia struggles with a lot is where the funding comes from. So typically, if funding is coming from, say, the aircraft in industry, then a lot of the journal papers and things like that will be geared up towards that industry because that's who's paying for it. But then there's a lot of other industries, such as Formula One, that could benefit from the same research. And I think that's where a lot of the gaps are really is, even though some other industry is paying for this for this research to happen, there's still a lot of potential um, other industries that can use it. I think with motorsport, it's quite unique in terms of um, you only need something to be better to be using it. Whereas if you're developing it for aircraft production or something like this, then it does need to reach a certain level of perfection because you've got, obviously for good reason, you've got a lot more sign off going into getting an aircraft out than you have in improving the speed of an F1 car. So I think within F1, people are willing to try new things a lot faster.
So is that a common theme in, let's say, Formula One or the motorsports, where these organizations, or teams, independent teams, they themselves fund some type of research?
It does happen. At Williams, we did fund it, not so much in terms of paying for universities to do a particular project, but when sometimes you have like a PhD project or you have master's level project, and then you would fund it in terms of allowing the student to potentially work on site with real data, use the company owned compute resources and stuff like that. So it does happen, but I'd say it doesn't happen enough. So you have potentially a couple of projects, but then there's a whole world of other research that's going on that kind of isn't getting tapped into as much as it could be.
Yeah. Okay, perfect. Well, I guess I'll just want to transition a little bit into, like, obviously you're an industry veteran by now. You've spent a decade working at some of the highest levels of, like, well, one in Formula One. That itself is a pretty big thing, and then but also like just in high performance, high paced environment. What advice would you have for people who are interested in getting, like, having an engineering career in, like, say, the motorsport world?
So I'd say, I mean, my biggest thing of advice would um, be good at problem solving. I guess if I go sort of, if I look at what I'm looking for when we're doing recruitment and you're sort of sifting through people who have applied and you go through the interview process in terms of what we're trying to weed out from people that we do take forward to, say, a technical. And the main thing we're looking for is the thought process someone goes through when solving a problem. So it's not even so much can they solve the problem we've given them, is how are they thinking when they're solving that problem? Can they articulate their thoughts? Because really, you're looking for someone who can work alongside other engineers, be very stuck on a problem and articulate that to other engineers, try and get help from other people on how to solve it. Yeah, I'd say one side is that. The other side is, I think a lot of people when they apply, they underutilize the cover letter. Lots of people use the cover letter to try to flatter the the recruiting person by telling you how great they think Williams is or something like this. Whereas what people should really use a cover letter for is to explain why they should be given the job. Um, and when you sort of try and analyze someone, this is a thought process which you're going through. You're reading their CV, trying to figure out why does this person fit what I'm looking for. And if someone can articulate that really well in a cover letter, then they're already one step ahead of the curve.
Yeah. So
Then the
focusing
other thing,
on,
sorry.
sorry, no, I'm just repeating. So focusing on problem solving, communication, that's big. How you present yourself, so like a cover letter. Yeah.
Yeah, and then the other thing I'd say is display the passion that you've got for whatever area that you're applying for, and have little side projects that demonstrate that passion. So if you're going in for a software role, that what what kind of displays that this is something that you really want to do. Or if you're going for a CFD role, have you done any little side projects that are interesting? And it's not so much to demonstrate, because coming out of university, you're not going to do a massive CFD project as such. But if you've demonstrated that this is where your passion is, then that counts for a lot.
Then also, I guess, can you just talk a bit about how to showcase, how to make the most, like, how do you actually showcase yourself? So stuff like a portfolio, or making, like, maybe being active on social media or something like that. Does that have an impact? Because I would assume a lot of students, they have side projects along with them, but then still out of those students, you would, like, a job, you would only pick one person. So what's that thought process that goes when you're hiring someone? Like, how do they best showcase their work?
That's a very good question. um, I would say include it in the either in the CV to sort of demonstrate these are things which they're passionate about. These are things which you're interested in. I mean, the cover letter is a very good place where you can talk about things like that. A portfolio is good. Social media content probably gets looked at less so during the recruitment process. I think it is mainly based on what the person's presented in their CV and presented in the cover letter. When you're looking at graduate positions, obviously, they're not going to have years of industry experience. So, and a lot of experience of candidates coming out of university or other areas is going to be very similar. So you kind of need something that makes you stand out a little bit. So some way to demonstrate that, yeah, that this is something that you're passionate about.
I see. And then I guess continuing with this theme, how important it is for like these up and coming engineers, people who want to pursue a career in engineering, to stay up to date with like the new trendy stuff that's going on with like machine learning, AI, all of this. Like big would that be now? Would you like if you're talking to an engineer, like how much of their time should they be spending like getting on top of all this new craze that's going on?
I would say it depends on the role which they're applying for. If they're going into sort of software related roles, then I'd say it's very important to stay on top of either current software best practices or new emerging technologies. Anything like that would help someone stand out above the curve. From an engineering perspective as well, I mean, I think if someone can come in and they're showing sort of that they're staying in touch with current trends, then it demonstrates that kind of passion and that will for learning. That's so important.
Perfect. Yeah. Well, I guess we'll close off with just these last two questions. First is obviously you are now running your own company with like these two missions that you described. In terms of the future of engineering, like say fast forward 10, 15 years, how do you foresee like this engineering landscape changing, especially with like, well, in two parts. One, with education, because that's something that you're working on as well, making education more personalized, more accessible, and then just in like practical engineering as well, like how do you foresee like stuff like AI, like all these new things actually playing out, like say in the next 10, 15 years?
So let's start on the education side. I think the impact that AI will have will be quite transformative in terms of making education accessible to a much broader part of the population. I'd say at the moment, a lot of the educational content is really geared towards this notion of how a typical human learns and studies. You can see that from exam content. It's all kind of similar sort of. If you don't understand that way of learning with exams and things like that, then that student's gonna struggle. Whereas with AI, it can really tailor that content and deliver it in a way that someone can. We might have someone who's visually impaired, for example, and the amount of resources available to this student currently is quite limited. Whereas with AI, it can take any content and it can transform it into a medium that's applicable to that person. So I think from that perspective, it's going to make it much broader. From the engineering side, I see it more as just another tool. So I don't think you're going to lose any engineers at all. It's just going to make the tools that these engineers are using just a little bit different. So, for example, I mean, ChatGPT is a great example. Before ChatGPT, people were using Google to figure out how a new bit of code they're not familiar with works. So I think people are just going to get faster at writing code, but then as a result of that, people are just going to be writing more code. So yeah, I think the number of engineers, things like that won't change. They'll just be using different tools.
Yeah, because that's a pretty hot topic in the software engineering world, which is like AI replacing software engineers now that it can generate code as well. So yeah, so you heard it here, folks. Engineers are here to stay. So
Yeah, definitely.
perfect. Yeah. Perfect. So how can people find you? So I'll have links for your company's website as well as your LinkedIn down below. Like if people want to get in touch, maybe get to learn more about your company, where can people find you?
Best base would be to reach out to me on LinkedIn. Yeah,
Perfect. I'll have your link down below. Well, thank you so much, Lawrence. I had a super fun time getting to know more about Formula One, your journey, your company. So thank you so much for doing this.
great. Thanks for having me. Yeah, it's been good fun.